All right, everyone, welcome back. Today, we're going to be taking a deep dive into something that sounds pretty futuristic. Fully homomorphic encryption.
FHE.
FHE, yeah. It's like, can we really be doing computations on data that's still encrypted
Yeah,
without, decrypting it first? It sounds wild.
it is. And it's one of those things that, when you first hear about it, you're like, wait, how is that even possible?
Right.
But it is.
It's like I have this locked box, and I can still do things with the stuff that's inside of it without
Without ever opening it.
opening it, yeah.
Yeah.
So how does this magic work? And as a CISSP candidate, why should I care?
Well, encryption is kind of the bedrock of cybersecurity, right? We use it to protect data at rest. We use it to protect data in transit. But traditional encryption has always had this limitation. You have to decrypt it to actually use it,
Right.
which means you're exposing it to potential threats.
Yeah, it's like having this really amazing
Right.
safe,
Right.
but to get to the money, to
Yeah.
use the money,
You got to open it.
you got to take it out of the safe.
Got to open it. Yep.
Yeah.
And so FHE solves that problem by allowing computations to be performed directly on the encrypted data.
So it's like I can count the money that's in the safe
Exactly.
without opening it up.
Without ever opening the safe. That's the analogy.
Wow. Okay, so as a CISSP candidate, I'm thinking about the exam too. Like, how does this tie into those domains?
Yeah, absolutely. So FHE has direct implications for several key domains, particularly security and risk management and asset security.
Okay.
So think about it. If you can process sensitive data without ever decrypting it, you are significantly reducing the risk of data breaches.
That's huge.
Right.
That's a huge risk management thing.
Absolutely. And it also strengthens your asset security posture.
Right.
Your data remains protected throughout its entire life cycle, even during computation. So it's like 247 protection for your data.
That's really cool. But before we get too far down this FHE rabbit hole,
Right.
can we just back up for a second?
Yeah.
I know that the CISSP exam covers a lot of basic cryptography concepts.
Absolutely. Yeah.
So can we just touch on those real quick?
Yeah, of course. So, I mean, you're probably already familiar with symmetric and asymmetric encryption, right?
Sure.
Think like secret codes with friends versus online shopping security. And FHE, it kind of takes those concepts to a whole new level by allowing computations on the ciphertext, on the encrypted data.
So instead of decrypting it every single time we want to use it, we can just work with it
Work with it directly.
in its encrypted form.
Yep, exactly.
That's a big leap.
It is. And there's this whole spectrum of homomorphic encryption. You've got partially homomorphic, which can only handle specific operations, like maybe just addition or just multiplication. And then you've got somewhat homomorphic, which is more versatile,
Yeah.
but it can be prone to errors. And then you've got the holy grail, fully homomorphic encryption, where you can perform any computation you want on encrypted data without compromising security.
That's amazing.
Yeah.
But this all sounds super complicated. Are we going to have to get really deep into math
Well,
to figure out how this works?
the math can get pretty hairy, but we can grasp the key concepts without, getting lost in all the equations.
Okay, good.
One of the most important ideas is something called homomorphic properties.
I've heard that term, but I'm not really sure what it means. Can you explain it in a way that a CISP candidate who's not a math whiz can understand?
Sure, yeah. So imagine you have this function that lets you add two numbers together and then encrypt the result. Okay?
Right.
Now imagine you could get the same result by encrypting those two numbers first and then adding the encrypted values together. That's basically what homomorphism means. You can perform operations in either order and get the same result, whether you're working with the plaintext or the ciphertext.
That's pretty cool.
Yeah.
It's like this secret code that works
Exactly.
even after the message is scrambled.
That's a great way to put it. And it's this property that allows us to do these computations on encrypted data without ever having to decrypt it. But there is a catch.
There's always a catch, right?
Unfortunately, yeah. Each time you perform an FHE operation, it introduces some noise into the ciphertext.
Noise.
Yeah, think of it like static on a phone line.
Okay.
Too much noise, and you can't reliably decrypt the data anymore.
Oh, so it's kind of like a game of telephone where the message gets
Exactly.
all garbled.
More and more distorted.
Yeah.
That's a great analogy.
So that sounds like a big problem.
It is. It's a major obstacle. But luckily, there's a very clever solution called bootstrapping, which essentially cleans up that noise and allows for continuous computation. It's like having noise-canceling headphones for your encrypted data.
Bootstrapping, that sounds familiar. Isn't there some guy named Craig Gentry
Yes, Craig Gentry.
who had something to do with that?
Yeah, he's a legend in cryptography. He's the one who first cracked the code of fully homomorphic encryption back in 2009. And bootstrapping was a key part of his breakthrough. It was a revolutionary moment that really opened up all these possibilities for data security.
So he was like the pioneer.
Absolutely.
But are there others who have like helped to make FHE a reality? I'm sure there's like tons of research going on.
Oh, yeah, tons. There's a whole ecosystem growing around FHE with contributions from academia, industry, government agencies, you name it.
So it's becoming a big deal.
Oh, yeah. It's a very big deal.
Who are some of the like key organizations that are involved in this?
Well, IBM has been a major player with their open source library called HeLib, which makes FHE more accessible to developers and researchers. And then you've got Microsoft with their SEAL library, which is also gaining a lot of popularity.
And I'm assuming Google and Amazon are probably jumping on this too.
Oh, of course, of course. And then you've got like more specialized companies like Duality Technologies, Unveil, Zama, who are really focusing on very specific applications of FHE.
Okay.
And let's not forget government agencies, DARPA, NIST. They're investing heavily in FHE research and standardization.
It sounds like everyone's interested in this.
Everyone is.
Yeah. So it's clear that this technology has the potential to really change things up in the cybersecurity world.
It does.
But I'm still curious about like the real world applications.
Right.
How's FHE being used today? And like, what are the possibilities for the future?
Yeah, that's a great question. And that's something that we can dive into a little bit deeper after a quick break. So we were talking about those real-world applications of FHE.
Yeah. Where's this stuff actually being used?
Well, let's start with cloud computing.
Okay.
Which is, I mean, a major concern for anybody in cybersecurity, right?
Yeah, especially for CISSPs. Cloud security is a huge part of that exam.
Absolutely. And with FHE, you can store sensitive data in the cloud and still perform computations on it without ever exposing that raw data to the cloud provider.
So even if the cloud provider got hacked,
right,
my data would still be safe.
Exactly, precisely.
That's amazing.
It's a game changer for data privacy and risk management in the cloud.
Yeah.
You know, thinking about it as a CISSP, you could be advising companies on how to leverage FHE to protect their most sensitive data in the cloud without sacrificing any functionality.
Yeah, that's pretty powerful.
It is.
Yeah.
Okay, let's move on to healthcare.
Okay.
Another area where FHE can really revolutionize how we handle sensitive information.
I mean, healthcare data is so sensitive.
It is.
You've got like people's medical histories and genetic information, all kinds of stuff that needs to be protected.
Absolutely. And with FHE, researchers can analyze patient data for things like research or diagnosis without compromising privacy.
So we can like advance medical research and improve patient care.
Right.
But still keep that privacy.
Exactly.
That's fair.
And it's not just about protecting patient privacy. FHE can also help prevent those data breaches, which are a huge concern in healthcare, right?
Oh, yeah.
For a CISSP, this means being able to recommend FHE as a way to enhance HIPAA compliance and protect patient data from unauthorized access.
That's a big win.
It is.
For the healthcare industry.
Okay, how about finance?
Finance, okay.
Another industry where data security is absolutely paramount.
Yeah, I mean, finance is all about trust.
Right.
It's about confidentiality.
Exactly.
You're dealing with people's money and their financial histories and all that.
Absolutely. And with FHE, financial institutions can perform secure transactions and risk analysis without revealing sensitive information.
So it's like every transaction has its own little invisible vault.
That's a great way to put it. It is.
Protecting it.
Yeah.
That's really neat.
For a CISSP working in the financial sector, you know, understanding FHE could be a major asset. You could help your organization implement FHE to protect customer data, prevent fraud, and ensure compliance with all those financial regulations.
Yeah, it sounds like FHE is like the ultimate weapon against financial cybercrime.
It has that potential, yeah.
Wow.
Okay, let's step into a different realm here.
Okay.
Artificial intelligence.
Hey,
learning.
Okay, yeah, those are really hot topics.
Huge.
in cybersecurity right now,
Absolutely.
especially for the CISSP exam.
And for good reason. I mean, these technologies are totally transforming how we detect and respond to threats.
Yeah.
But they also raise some concerns about data privacy.
Yeah, because they need so much data
Right.
to learn and to improve.
Exactly. They need massive amounts of data, and that data is often very sensitive.
Right.
Imagine you're training an AI model to detect fraud. You need to feed it real financial transactions, right? Which contain personal information.
So that's where FHE comes in.
That's exactly where it comes in.
Oh,
With FHE, you can train AI models on sensitive data sets without ever accessing the underlying data.
Wow.
So you get the benefits of AI and machine learning without compromising data privacy.
That's like having your cake and eating it too.
It is.
That's pretty amazing.
It is pretty amazing.
But I keep coming back to this idea that FHE, like, the computations must be so intense.
Right.
Like, how can it really be practical?
That is a great question, and it's one that researchers are actively working on.
Yeah.
One of the promising solutions is something called hardware acceleration,
Okay.
which basically involves using specialized hardware to speed up those FHE computations.
So it's like giving FHE a turbo boost.
Exactly, a turbo boost.
Nice.
And with, advancements in hardware technology, we're seeing some really significant improvements in FHE performance.
That's good. That's good to hear.
It is.
So it sounds like it's becoming more and more viable every day. Yeah. I'm curious about the CISSP exam, though. Like,
Right.
are there any specific topics related to FHE that we should be, like, really focusing on?
Well, the CSSP exam is all about breadth and depth of knowledge, right?
Right.
It's not just about memorizing facts, but really understanding the underlying concepts and applying them to real-world scenarios.
Yeah.
So while you might not see very specific questions about FHE algorithms or implementations, what you have to understand is how it fits into the bigger picture of cybersecurity.
Okay.
Okay.
Right.
Right.
So we should be thinking about how FHE relates to different CISSP domains, like security architecture and engineering, or
Yes.
communication and network security.
You got it.
So, for example, if you're designing a secure system, how could you incorporate FHE to enhance data confidentiality?
Right. Or how could you use FHE to secure communications in a zero trust environment?
Exactly.
Well, I mean, the CISSP exam is all about connecting the dots, understanding how all these different technologies and principles work together to create a secure system.
Right.
And FHE is a piece of that puzzle.
So it's not just about knowing what FHE is, it's about understanding how it impacts everything.
Absolutely.
Yeah.
And as FHE continues to evolve, those implications are only going to become more significant.
Right.
Right.
Yeah. This has been a really interesting conversation.
Yeah.
I'm starting to see how FHE is more than just some futuristic technology.
Yeah.
It's a real tool that we can use today.
Absolutely. It's a tool that has the potential to really transform cybersecurity as we know it.
Wow.
And for those who are prepared to embrace it, it offers a very unique opportunity to be at the forefront of innovation.
That's well said. I like that.
Thank you.
We've covered a lot today. We talked about the basic principles of FHE, and then all the real-world applications and how it ties into the CISSP exam.
Mm-hmm.
But before we wrap things up, I want to touch on one more important aspect.
Okay.
The ethical considerations
Yes.
of FHE.
That is a crucial point.
Yeah.
As with any powerful technology, you have to consider the benefits, but you also have to consider the risks.
Right.
Right? Especially when it comes to data privacy and security.
Yeah, because FHE can be used for good,
Right?
but it could also be used for bad.
Absolutely. Imagine criminals using FHE to encrypt their communications.
Oh, wow.
Or their financial transactions, right?
Wow.
Making it much harder for law enforcement to track their activities.
That's kind of scary.
It is a bit of a chilling thought.
Yeah.
It's a reminder that any technology can be a double-edged sword.
Right.
It really can.
Yeah.
So it's essential for CISSPs to be aware of those potential risks and to really think critically about the ethical implications of FHE.
So it's not just about the technical stuff.
No.
It's also about responsibility
Absolutely.
and using it the right way.
Exactly. As cybersecurity professionals, we have a responsibility to make sure that these technologies are used for good and that they don't create new vulnerabilities or undermine trust in the digital world.
I like that.
Thank you.
Those are really powerful words.
Thank you.
And I think that's a fitting note as we kind of conclude our deep dive into FHE.
Sure.
But before we sign off,
Yeah.
I want to leave our listeners with a thought-provoking question
Okay.
to ponder.
I like it. Go ahead.
With FHE becoming more and more powerful, more accessible, like how do we make sure that it's not being misused?
Yeah.
I mean, it's got to be a tough question.
It is a really tough question, and there are no easy answers, really. But I think, it all starts with education, right? CISSPs need to understand how FHE works, what it can be used for, and what the risks are if it falls into the wrong hands.
So knowledge is power in this case.
Yeah.
The more we understand about it,
Yeah.
the better we can use it for good.
Absolutely, yeah. We can't just react to things as they happen. We need to be proactive. We need to think ahead, anticipate the challenges, and figure out how to address those, like developing strong security protocols, clear ethical guidelines, that kind of thing. And we need to make sure that FHE is implemented in a transparent and accountable way.
So it's not just about having this really cool tool. It's about making sure the right people are using it.
Right. And this is where, the CISSP Code of Ethics comes into play. Because as cybersecurity professionals, we have a responsibility to act ethically, to protect people, society, to make sure that the public has trust and confidence in the systems that we're building and using.
So it's more than just like technical skills at that point.
It is.
It's about like doing the right thing.
Absolutely, yeah. Integrity, good judgment, and using your knowledge for good.
I like that.
Thank you.
So FHE has the potential to be a game changer, right?
It does, absolutely.
It's a powerful technology that could reshape cybersecurity as we know it, and it's up to us as CISSPs to make sure that happens in a positive way.
Absolutely.
That's a great point to end on. If we've talked about like everything from the technical details of FHE to the real-world applications and the impact it has on the CISSP exam. And of course, we just touched on those really important ethical considerations.
Yeah, it's been a great conversation, really insightful.
It really has. And, this is just the beginning for FHE. It's still relatively young technology, and we're just scratching the surface of what it can do.
I'm really excited to see what the future holds for FHE and, how it's going to shape cybersecurity.
Yeah, me too. And for all of our CISSP candidates out there, this is something to keep an eye on. It's a topic that's worth learning more about, exploring further, and really understanding.
It's fascinating, yeah. The future of cybersecurity is encrypted, and FHE might just be the key to unlocking it.
Love that. And on that note, I think we'll wrap up our deep dive into the amazing world of fully homomorphic encryption. Until next time, stay curious, stay secure, and keep on learning.